I'm going to tie that into our other cycles. So you guys were supposed to do a carbon cycle drawing and answer some questions about the carbon cycle, which I'll be grading soon. So that'll be on the next slide. Let's talk about the carbon cycle. So carbon cycles, just like oxygen, between photosynthesis and respiration, which we studied in Unit 2. The decomposing of dead organisms puts carbon back into the soil, so that's good. So when decomposers break those organisms down, they can put some of that carbon into the soil for plants and other things to use. The deposition, which is just a fancy word for burial, the deposition of dead organisms can put carbon into the ground, and over time, over huge amounts of time, like millions of years, they can actually become fossil fuels. So down here we have coal and oil. And then humans release the carbon into the atmosphere by burning those fossil fuels in cars and factories, which is actually now imbalancing the cycle, which leads to, again, what's called the greenhouse effect. And over time, the greenhouse effect has caused global warming. And now the new concept from those things is like global climate change, or what I call climate imbalance, where we're seeing imbalances with like the increased hurricanes and things like that, where it's not balanced the way it was, and the weather patterns and climate patterns are changing because of the burning of these fossil fuels. And also when we cut down and burn down forests, it's only making it worse because the forests can help absorb that carbon dioxide. But as we destroy those forests, it's not helping to reabsorb the carbon dioxide anymore. And when we burn the forest, it's actually just creating more carbon dioxide while also destroying and killing the organisms that can help reabsorb it. All right, let's walk through the nutrient cycle here. So what we see is most of the carbon is found in the atmosphere and the ocean. And we see there's a number of ways for it to come down. So we see it goes into the plants in photosynthesis. The animals can eat it and do respiration, and then when they breathe it back out, it goes back in the atmosphere. Over here we see that these organisms can decompose and put it back in the soil, or maybe they can get buried and deposited, and over, again, huge amounts of time. Most of the fossil fuels we have come from the Carboniferous period, and that is hundreds of millions of years ago. So we can't just like make fossil fuels. It's not going to work like that. And then here it's showing that humans are using it, and when we burn it, it goes back into the atmosphere. And normally in class, when I have kids draw this, I have them actually at a car with an arrow going into the atmosphere, because a lot of cars are burning fossil fuels, which is also another way that it's going into the atmosphere. I don't think factories actually burn as much as all our millions of cars do. We also see volcanoes can naturally put it in the atmosphere, and we also see the ocean can release it, and it can go back and forth between the ocean and the atmosphere. We also see all those same processes pretty much happening in the ocean, where we have algae that's doing photosynthesis, and then it's getting eaten by animals that are doing respiration, and we see very similar cycles happening over here. So again, as far as the forests and protecting our producers, here we have plants, and then down here we have algae. They are absorbing carbon dioxide for us, so we need to protect those organisms by not chopping and burning down forests, as well as not polluting and killing off the algae, because they're helping control the carbon dioxide as opposed to increasing it in the atmosphere. All right, the nitrogen cycle is our last thing here. So nitrogen is necessary to create amino acids and proteins. So organisms absolutely have to have that cycling through their ecosystems. And this is kind of a little step-by-step of how that's going to happen. So bacteria will convert nitrogen gas in the air. Most of the air we breathe, like by far, is actually nitrogen. So they're going to help convert nitrogen gas from the atmosphere, and the term for that is nitrogen fixation. And they're going to turn it into forms that can be used by plants, which I'll show you on the next slide, and then they can be eaten by animals. And so now it's gone from the air to the bacteria to the plants to the animals. Then when those organisms decompose, like their waste matter, like poop and pee basically, and dead organisms, when they decompose, it provides nitrogen back to the producers and the soil and stuff, and so they can keep growing. But we have talked in class about pollution on farms and a lot of chemicals that are being sprayed on farms. So farmers will put nitrogen fertilizers into their soil to grow plants. But some of these are really harsh synthetic chemicals that actually can destroy the soil, and so they end up having to spray more chemicals. So as they destroy the organisms in the soil with these chemicals, now it's becoming more like dirt, and plants aren't going to grow in it like crops and stuff. And so they have to spray more chemicals to feed the crops. So it becomes chemicals on top of chemicals on some of these farms, which has resulted in a lot of pollution, or farmlands in some cases being destroyed and stuff. And this is one of the things that organic farms do, is they are not allowed to use these chemical fertilizers, and they're using more natural methods like compost and manure and other things that do not destroy the soil, but actually the organisms in the soil thrive off of those forms of fertilization and fertilizer. So here we go. So we see here most of it's in the atmosphere, and I want to go this way. So here we see some roots, and on the roots are little bacteria, and they're doing nitrogen fixation. And then we also have bacteria in the soil that's doing that, and they turn it into this molecule, which I'm pretty sure is ammonia. And then it's being taken up by producers. So now the plants can use it. So it was in the air, and the bacteria made it so that plants can use it, which is really cool and important. Why we need healthy organisms in our soil that can do nitrogen fixation and take it from the air and give it to the plants. And we see then the animals can then reuse it, and then they decompose when they die, or excrete, which is like pooping and peeing, and that puts it back into the soil again, and we get a nice little cycle just right here. Here is our farm, which is manufacturing synthetic or man-made fertilizer and putting it on the farm as well. And some of those are going to maybe be healthier and less polluting than others. We see that lightning can actually help with some of this, which is kind of weird. And here we have some other bacteria making some other forms of nitrogen that organisms can use. One way it goes back into the air is these bacteria do what's called denitrification. But let's focus over here, where we have these molecules being taken in by the producers, like the algae and the plants, which then can grow from it. Then it gets those plants and algae get eaten by the consumers, and when they decompose or poop or pee or whatever in the water, then it can go back into the cycle, and hopefully these nutrients will continue to cycle in healthy ways. And I do feel that organic farming is much better for this cycle, because it's not using these really harsh chemicals and is using more natural materials to replenish farmlands and feed the crops and keep this nitrogen cycle going in a healthier way. Hopefully some of you have some organic products at home, and now you're starting to understand a little bit why they're a good choice to make. Okay, and that's it for the interdependence notes. I mentioned these birds earlier that will sort of hang out on African animals. This one is all up, they'll actually go up in their ears and take bugs out of their ears, because these animals can't do that for themselves. That's a really great benefit. And then the bird is also getting food. So I'm not going to tell you the answer to this question that's eventually going to get posted. I want you to figure out, based on that relationship, where the bird is getting food as it cleans the ears of bugs in this. I think this is some like an impala or something. There's a term for that I already went over. When food for this one, getting cleaned up for this one, figure out which form of symbiosis that would be called, and that will be on the next thing I'm going to start working on. Now that I've made my video lectures for the start of ecology, I'm going to start working on a program that my friend told me called Style. We're going to make like online questions, and it's going to grade itself, and I'll be able to tell how you did. And you got to watch the videos and listen to the stories in order to answer those questions. So I guess the last question will probably be about this scenario. All right, guys, like I said before in one of the videos and a lot of the emails, take care of yourselves, do the social distancing, help out at home, be a really great role model for your younger brothers and sisters and your younger cousins. Like I said before, they're going to look up to you, and they're going to see how you handle the challenges that we're dealing with and how much you're helping at home, and they're going to follow your lead. So I think it's a really great time for you to show them how to be responsible and respectful and helpful and supportive for your parents and your grandparents and whoever else you're around, as well as for them, and have some fun with them too. Play video games, read to them, make some games in the house, whatever, and have fun and try to enjoy that time with your family. All right, guys. See ya.